Now that we know what the t-distribution is and how it works, we're going to have to be able to find the t-values for it. I'm going to illustrate this with some examples, but the instructions are right here. All right, so before we even get into finding them, let's talk about what they are. And the answer is there are a couple things. So you have critical t-values, t sub alpha. Now, if you remember, you've seen that notation before. You saw it in chapter 7 with z's. So they have z with a little alpha. We also saw it in section 9.1. By definition, that means that that little subscript is the area in the right tail, right? The right tail right here, which I have shown to you on this lovely picture here. So here's T alpha, and that area right there is alpha by definition. So we often notate it by the way T alpha comma degrees of freedom, because since every curve has its own degrees of freedom, we'll put a little comma in there to talk about which curve we were using. Now we're going to use single tail values like this. So you're going to draw pictures like this in chapters 10 and 11. But this isn't what we need so much for confidence intervals. If you remember when we saw the formula a second ago, and we're going to see it in a minute as well, actually in about 10 minutes, there's a formula here for the confidence intervals, and it talks about T alpha over 2. See that middle portion of this formula right here? That's our critical value, just like the Z alpha over 2 was for our proportions. And don't forget, this is from your formula sheet that you get to use on your exam, so you don't have to memorize or write any of this stuff down. You just have to be able to use it. All right, so let's go back and figure out what we're looking at then. So since it's alpha over 2, what that's going to mean is you're splitting it in half. You're cutting alpha in half. You're going to put an alpha over 2 over here on the right and alpha over 2 over here on the left. So T alpha over 2 is the T value that has alpha over 2 to the right of it, right? And then there's another one on the other side that has alpha over 2 to the left. And your confidence level is the middle gooey center, right? Now, 0 is still the mean, right? So your mu is still 0 in the center. But you're going to have two values, but they're going to be the same number because of symmetry, right? Since 0 is in the center, one's positive and one's negative, and they're the same number. Now, there's two ways you can find these. One, you can just use your calculator. Inverse T, use the left tail area with inverse T, which is weird because your notation talks about the right tail area. By definition, that little subscript is the area in the right tail, but the calculators have to take left tail area when they put them in. So that's one way you can do it. Or if possible, you can use your t-table. Now, but the t-table, the one problem with that is that it doesn't have all of them. Now you might be wondering, where is the t-table? Well, it's in that notes packet, right? So before we get to the confidence interval formulas, that's the chi-square table, which we'll deal with later in this chapter. But right here is the t-distribution table. And it even reminds you right there at the top, it's the area in the right tail. Okay, so we'll deal with that as we do this problem. So let's practice. We want to find the critical t-values that correspond to 95% confidence when n is equal to 17. Oh boy. All right, so I'm going to have to draw a picture and find a whole bunch of stuff. 1 second. Okay, I have a t-curve drawn here, and I know it looks like a z-curve, but it isn't. It's a t-curve. It's technically slightly fatter in the tails and so on. Okay, so I have my t-curve drawn. I have alpha over 2 over here on the right, alpha over 2 over here on the left, and then I'm going to put little arrows down so that it points down to the curve. 1 second. There, I just labeled it a little bit better real quickly for you. So you got T alpha over 2 over here on the right, negative T alpha over 2 on the left. The middle is 95%, so 0.95. Okay, so far so good. So now the question becomes, if the middle is 95, we need to be able to find alpha first of all. Well, alpha is the area in both of the tails for this problem because you're splitting it in half for single tails. So that means that you have alpha is the complement. If you remember, alpha and the confidence level are complements of each other, but that's both tails. So alpha over 2 is the area in each tail. Right? Now, if you're going to use the table, that alpha over 2 is going to be the column you're going to go to in the table, which we'll talk about in just a second. Okay. All right, so now what about the row? What's our degrees of freedom? Well, the degrees of freedom, remember, comes from your n. So since you have 17 is your sample size, degrees of freedom is n minus 1, which is 16, right? 17 minus 1. And that would be the row of the t-table. right? If you use the table, if you use the t-table. All right, so let's use the t-table and just see how it works real quickly. And then I'm also going to show you how to use it with the calculator. All right, so the table is great and quick, but the problem is it doesn't have everything. The table only has 12 different alpha over 2 values and, you know, maybe what's 50 or so degrees of freedom. All right, so the area in our right tail, if you look at it, we should have labeled it, and I will label it, because once you figure out that area, you should label up here on the graph. And as with most problems, you have to label the whole curve. So this is 0.025 over here, right there. And that means this other side is also 0.025, like that. There we have it. Okay, so each of those tails is 0.025. In particular, let's look at the area in the right tail over here. Now remember, that's what it says right here at the top, the area in the right tail. So I'm going to go to 0.025 as my column, and then over here I have different degrees of freedom. So I want to go to where it's 16. So 16 and degrees of freedom, degrees of freedom is 16, 0.025 as my tail puts me right there at that one. 2.120, right there. Okay, and you probably don't want to actually put a box on yours because you're going to keep using this table over and over for different problems, but that's how to do it. The other way to do it is to use inverse t. Now inverse t by definition wants the area in the left tail. So, but it doesn't really matter because you could just use the 0.025 again. So you'd want inverse t, and then you want the area in the left tail, which is 0.025, comma, and then it wants your degrees of freedom, which is 16. Okay, so let's see here. Let me grab the calculator, go to second distribution. You want a number 4, which is inverse t, and you want to tell it the area, and it just says area. You have to know, oh, that's the left tail area. And then degrees of freedom is 16, paste, enter. And because I put 0.025, it actually found the one on the left. It finds the negative 2.120 because the 99 would round up, right? So it found the one on the left, like that. Now, if you wanted to find the one on the right, you could do the same thing, right? Inverse t, but instead of doing 0.25, for the one on the right, you use 975. Enter. Because, hold on, there it is. It's the same number. Now, the 975 happens because 95, 0.95 and 0.025 add up to 975. But you don't have to do it twice. They're the same number, so it doesn't really matter which one you find. So if you use inverse t or if you use the table will give you the positive one, the inverse t gives you the negative one, but it doesn't matter because we were actually interested in the values altogether, right? And the answer to the values is plus or minus because it wants both of them, critical t values, plural. So I'm interested in finding both of them, and that would be both of those. So plus or minus, and I actually did the subscript as 0.025 comma 16, just to note to myself that I was doing degrees of freedom 16 on this one. And that's it. Keep in mind, if you have a TI-83 or an 84 that wasn't upgraded, you're not going to be able to do the inverse T. You're going to have to use the table. But the danger with that is that sometimes I give you ones that aren't in the table and you're stuck. You're going to have to go online and find it or do some other thing, or basically pick the closest value to what you need and hope for the best. All right, so now let's do it again, but this time we have alpha is 0.005 and n is 35. So we have to find the critical values and find what confidence level would use that critical value. Well, the confidence level is easy to figure because if you recall, alpha and C level are complements of each other. We saw that back in section 9.1, and we're going to see it again and again. So the middle is 0.995, but the edges are going to be half of alpha. So alpha over 2, which is 0.005 over 2, which is 0.0025, right? I just took 0.005 and cut it in half. Okay, so that's alpha over 2. So that's going to be the column of the t-table if it has one, which I believe it does. And then the row would be 34 because 35 is my sample size, so my degrees of freedom is 34. All right, so let me relabel and remake my graph. 1 second. I just took a moment and made a more accurate graph for you guys because I wanted you to see what would happen here. So if you look at the one for A, it's got 0.025 in the tails. That means the tails are 2.5% of the graph, right? Each, right? So each 2.5%. 0.0025 needs to be farther out. Those tails are really small because the center portion of your curve is 99.5%, right? So they're even further away from the center. At least that's the plan. Right, so I just drew that to scale so you guys could see it. And actually it's a slightly different curve if you'll notice because the one up above has 16 for degrees of freedom and the one down here has 34 for degrees of freedom. So notice how the tails are a little bit smaller. Like we said earlier, the larger your degrees of freedom, the more like a normal curve it gets. All right, so when I go to inverse t, I'm going to want to type 0.0025 because that's the area in my tail. My degrees of freedom is 34 now, it's not 16. And I don't know what this is, but I will find it. So let me grab my calculator, go to second distribution. I want to pick number 4, so you can just press 4. And I want to type 0.0025. 34 is my degrees of freedom. And I pressed enter on paste, and I pressed enter again, and I got 3.002 negative. So negative 3.002 approximately. So that means that our answers are 0.0025 comma 34 because that's my degrees of freedom, and that's 3.002. I don't need to worry about the plus or minus because the plus minus symbol will take care of it. The positive one's on the right, the negative one's on the left. And just to prove you could find it with the table as well, 0.0025 is this column over here. It's third from the right. And then we want to 34 degrees of freedom. So we're going to be going down here, and there it is. 34 degrees of freedom, 0.0025. And remember, don't highlight this table because you'll get very confused because we're going to keep using it over and over in chapters 9 and 10 and 11. So just for the moment, kind of realize, use your fingers and point to the one you want. So the table finds the one on the right, the positive one. The calculator would have found it as well if I wanted to. To find the positive one with the calculator, I would have just needed to put 0.9975 because that's the middle and the left-hand region together. Oops, I just closed my calculator. There, it's back. All right, so 0.9975, 34, paste. And I'm getting that by adding 0.995 and 0.0025 together in my head. But because you're looking for the left tail area to put into a calculator. So if you add that center portion plus that tail over there, you get that. But again, you don't have to worry about it. You can just find the one on the left with 0.0025 and then just put plus or minus on it to get both of them. All right, so we answered both questions. The critical values would be 3.002 plus or minus, and then the confidence level is 99.5%. Okay, so now what about t.05 comma 20? So I'm giving you the value in a weird symbol form that I want. So I'm telling you that the area in the right tail is 0.05 and my degrees of freedom is 20. That's what that symbology means. So let me make a picture and type that up. All right, let's figure out what we know from this. So when we look at it, we can see that when it gives us that symbol, the 0.05 comma 20 down there in that subscript, that's letting us know two things. It's letting us know that the area in the right tail is 0.05, and it's letting us know the degrees of freedom. I'm actually going to put the degrees of freedom on top because we need that less than the alpha. So let me do that. All right, so I know that it's alpha over 2 equals 0.05, which means, by the way, I have another side on the flip side, which is also alpha over 2 equals 0.05. Now what I'm looking for are the two t alpha over 2's, right? Technically one's positive t.05 comma 20 and the other one's negative. But first thing I'm going to do is figure out where I got that 90 from. So if alpha over 2 is 0.05, that means that alpha is 2 times 0.05, which would be 0.10, right? That's the area in both tails. Right? That means that the center area has to be the complement of that. There we go, 90%. Right, that's the area in both tails. So I've already answered one question. What confidence level would this use? That green answer is my answer. That's the confidence level. All right, now I just have to find the values. So I know that it's the row 20 and then the 0.05 column. That's one way I can find it. Or I could use inverse t. So for inverse t, it would be inverse t 0.05. And then degrees of freedom is 20 because it was given to us as 20. There's no need for subtraction on this one. So let me grab the calculator, go to distributions, pick number 4. I'm going to say 0.05, 20, enter. And there it finds it, negative 1.725 or so. All right, now that's not actually the one they were looking for. They want us to find t 0.05 comma 20, which by definition means the area in the right tail is 0.05. We just found t 0.95, if you will. We found this one over here, or negative t 0.05, right? So we found the negative value, but we want the positive value. It's very clear it wants us to find the positive. It doesn't want us to find both. It doesn't want us to do the plus or minus thing. It just wants us to find one of them. So the answer would be t 0.05 is equal to 1.725. And since this is rounded, technically it's approximation, and I should have done that for all of them. They're approximately, they're not exactly because there's rounding going on here. So they actually only asked for the positive value. That's what this symbol is. This symbol is asking for the positive one because the area in the right tail is 0.05, which means you're on the right-hand side. If they want the negative one, they'll put a negative in front of it, or they'll call it t 0.95 because 0.95 is to the right of that. All right, now let's look at the table real quick before we're done. So we knew our degrees of freedom was 20, and we know that our alpha is 0.05. 0.05 is right here. That's the column 0.05, and that's the row 20. So that'll do it. Just remember that the table does not have all possible values. That's the danger of relying on the table too much, because I can give you ones that don't have values that are in that table, and you're going to be stuck unless you can use inverse t from your calculator. All right, now we've learned how to find critical t values. In the next video, we're going to learn how to apply them into the confidence interval formula. See you then.